It was about hacking chemical plants, which looked really interesting. So thank you for coming along to this track and not that one. So first, a quick intro to myself. I first really caught the security bug when I was playing Cybersecurity Challenge UK online, and it had a number of different fun puzzles that you could solve. And from there, I ended up meeting a lot of other people who were into the same thing. And we formed a security team, CTF team called Crown, which for a few years was the strongest capture the flag team in the UK. I co-founded a website called Crypto Hack, where you can play lots of fun challenges for learning cryptography. And I currently work as an application security consultant at a company called Include Security. So the structure of this talk, first of all, I'm going to talk a bit about deep versus wide vuln hunting and what I mean by that. We're going to look at Linus's law, which is kind of a backdrop to everything that we're going to be talking about today. And then next, I'm going to compare methods for hunting down vulnerabilities across thousands or even millions of open source projects at the same time, and ranking which ones have been more effective than others. Then we're going to look into mass assignment, which is the vulnerability class that I decided to narrow in on, and I will talk about why at that point. And then we're going to deep dive into the discovery and exploitation of a particular vulnerability that I found in the top most starred GitHub project. And finally, there'll be takeaways for both attackers and defenders from this research. So bear with me here, this is quite abstract, but normally when I do pen testing as part of my job, I think of it as being quite a deep activity where you look at a single project or a group of related projects, and then you really try and understand it very well. You look at the business logic, and you try and find as many different types of vulnerabilities as you can in those projects. But I wanted to try something different and change up the gears a bit and do something more which I would call wide vulnerability hunting, which is where I wanted to kind of specialize in just one particular vulnerability class and then try and search for it across as many different code bases as I could and see if I got lucky and score some hits. So I don't need to understand any particular code base very well. I just want to kind of, check if there are exploits out there anywhere, because there probably are if you look at enough different code bases. And the silly metaphor that I came up for this was the type of industrial fishing known as trawling. It's obviously very environmentally unfriendly, but basically you take a massive net and then you drag it along the bottom of the ocean. You're normally looking to catch some nice big fish, but as a result of that, you're going to get some bycatch, the wrong species or some smaller fish, and then you have to chuck those back in the ocean. So those will be false positives, but the idea is that you're going to get enough of the good fish that you want that would probably be uneconomical to find via other methods. And so the only ocean that it really makes sense to fish in is GitHub. Absolutely enormous now. It has over 200 million open source repos. And something that's always interested me has been Linus's law. So this is an idea which is put forward by Linus Torvalds, which is that given enough eyeballs, all bugs are shallow. And what he means by that is the larger the community around a project, then normally the better the higher quality the code will be, the less bugs it should have, the less security vulnerabilities it should have, because you'll have more experts who are able to contribute. And the corollary of that, of course, is that open source software is better than closed source software, because open source software can be viewed and read by anyone. But if you actually look at the conflicting evidence, if you actually look at the evidence about this, it's actually quite conflicted about whether that's true or not. So one paper I found couldn't find any real empirical evidence to support Linus's law, whereas another one I found, they looked specifically at Google's projects, and they did find that Google projects that had more stars on GitHub tended to have higher quality code and less security vulnerabilities and quicker bug fixes than the smaller projects. So how are we actually going to search for vulnerabilities on GitHub? So the obvious way is we'll find some kind of known bad functions or bad strings, which often lead to security vulnerabilities, and then we'll just find a way to search them across every single project on GitHub. That's kind of like the obvious starting idea. So I've got some payloads here. Probably you're familiar with things like remote code execution, shell exec in PHP, os.system in Python. Normally these can lead to bad things happening. Another obvious one is SQL injection. You could write regexes, which will find how SQL injection exploits can occur in various languages. But for this research, I wanted to avoid things like SQL injection because any developer worth their salt these days is aware of it and normally tries to design against it. Of course, you still find them now and then, but I've had a lot of success in finding things like unsafe deserialization, XXE vulnerabilities, mass assignment, that kind of thing. They can be very high impact vulnerabilities, but developers are less aware of them and often forget to protect against them. So they seem like the right kind of thing to look for here. So now we've got a rough idea about how we want to search for things. We need to find a tool for actually doing the searching, the search engine. So the obvious one is GitHub Search. And this has now changed, but when I was doing this research and first starting last year, the first port of call is obviously just, use GitHub Search. And it's actually really bad for this. Not just for this, but it was just a really bad search in general. It didn't recognize symbols. So if you searched for code, it wouldn't understand dots or brackets or equal signs or anything. It was just a keywords-based search. It didn't have any kind of regular expression support. And worst of all, probably, there's no sorting by relevance. So on GitHub, you have millions and millions of boilerplate repos, forks, just my first project, that kind of thing. And you don't want to be searching through thousands of those when trying to find security vulnerabilities that are actually against, active and fairly big projects. So earlier this year, GitHub massively improved their search. It now recognizes symbols. You can search for literal code strings across all of GitHub in a very fast way. Now has regular expression support. But it still has the big problem of not being able to really find relevant projects and relevant results. And here we're just looking for, big GitHub projects, not random stuff that people have just thrown out there. So an example of this is using GitHub Search today and using a mass assignment payload. I'm going to explain a bit more how that works later because it's not the most well-known bug class, but here it's like, great, we can find some matches. These projects are probably vulnerable, but when you actually look at them, you find, this has just been abandoned 7 years ago, has a small number of stars. It's not really the kind of big fish that we want to catch. So the next thing that I got really excited about was Google's BigQuery. So BigQuery is a data warehouse as a service that basically allows you to run SQL queries over an enormous data sets. And they actually had a 3 terabyte data set of all of GitHub's data on it. So when I saw this, I was like, great, this looks like exactly what I need. And this hasn't escaped the attention of some other security researchers, such as this guy, Sjoerd Langkemper. If you're into application security, his blog is fantastic. And here you can see he's doing select repos, where the language name is PHP, where it contains this function that he's looking for, and ordering it by the repo watch count. So great. It's like now we can search for particular patterns and we can sort by the popularity of the repo and potentially find some interesting stuff in some pretty big GitHub repos. But there were 2 massive problems with this, with BigQuery for this. Is I found that the dataset hadn't been updated since 2016 and it's also really expensive. So Google give you $300 in free trial credit, which is very generous of them. But I found that the very first query that I ran against this data set cost me over $200. So obviously this was going to become too expensive very quickly. So the next idea I had was to write a script which would use GitHub's API to pull down a large number of the top GitHub most starred repos, and probably in a particular language. So I was thinking about, how about I just download the top 10,000 repositories that are written in Python, and then I locally run some static analysis tools against them. I could start off with some default rule sets, but then probably write some custom rule sets of my own based on my own particular vulnerability class, and then hopefully find some cool stuff that everyone else has missed. So my two favorite static analysis tools are CodeQL and SemGrep, and I'll briefly talk about them here. So CodeQL is a way of it basically reads a code base and then translates it into a database which can be queried in some quite powerful ways. and it understands control flow between different functions. So you can actually do taint tracking analysis, and you could do source to sink flows. So you can write queries that look for places where attacker input can flow in the back end of an application all the way to a vulnerable function. It's a brilliant tool, but it has a very steep learning curve, and I spent a few days trying to get the results that I wanted, and wasn't super successful with it. It's also not open source. It's actually owned by GitHub now, and it's part of their advanced enterprise things. You are allowed to run it against open source projects, but you are not allowed to run it against closed source ones currently. And it has another big limitation. If you're using it with a language like C++, you need to be able to build the code base for it to make the database. One thing that I would say, though, as a side note, is that GitHub have made it very easy now, if you have an open source project on GitHub, to add CodeQL as part of the CI/CD. So if you go into settings, it's just like a 2-button thing, and they will just run the default rule sets. And for certain languages, like particularly Python, it's really good. So I don't see many open source projects actually doing this, and I think it's a quick win, which shouldn't turn those down. So the other one is semgrep, and I'm a big fan of semgrep, like a lot of security engineers and researchers, just because it's got great defaults. It's straight out of the box. You can run it on projects, and it will figure out which rule sets to use, and it's very easy to write custom rules as well. But unless you do some customization of it, it's likely to find quite a lot of false positives. So in the end, I think if I was going to do this research again, I'd probably choose this approach, this number 4 approach, with downloading repos locally and running static analysis tools on them. But at the time, I actually just moved on from this and thought that I will try and find something a little bit easier. So the thing that I eventually found, which kind of felt like hitting the jackpot, was I found this third-party GitHub searching tool called grep.app. And the thing that's really great about it is it's similar to the current GitHub code search, but they've only indexed the top 500,000 GitHub repos. So that means if you search for vulnerable code patterns here, you're very likely to find, quite important repos or valid results there, without having to sift through a lot of cruft and starter projects. So yeah, grep.app, perfect. I realized we found the search engine that we need. So now I wanted to choose the vulnerability type. So I want something that's easy to search for, where I can put queries in quickly and find this type of vulnerability. I want something that developers are largely aware of, and I want something that's often leading to high impact vulnerabilities. So the one I chose for this is mass assignment. I'm going to do a quick refresher on what mass assignment vulnerabilities are in the context of API security. So you've got the OWASP definition there, and although it's correct, I find that it's one of those things that's just best explained with an example, so I'm not even going to read it out. So on the right there is a kind of pseudocode, very, very basic idea of what a web application would look like that's vulnerable to mass assignment. So at the top we have the API post route for users/register. If you make a post request to that route, then it calls the register user handler. The register user handler takes the post request body and saves it as a new user model into the database, as a user object into the database, I should say. And then the user model itself has 3 properties on it: username, email, and role. And role has a default value of user. So by default, if you register, you should be a user. So the expectation from the developers of this false application fake application is that when a post is made from the front end to /users/register, it will have a name and an email in it, and then a new user will be created. But there's a huge problem with this code, which is that an attacker can then add an additional property to their request body with the role set to admin. And there's nothing in the code that's stopping them from doing that, because the register user handler is taking the entire request.body there and persisting it to the database as a new user. So at the core of mass assignment is the idea that certain properties of objects should be allowed to be changed from inputs specified by the user, and certain shouldn't, and then they've forgotten to actually filter for the properties which you shouldn't be allowed to change. So the most famous example of a mass assignment vulnerability was about 10 years ago now, with a researcher called Igor Homakov, and he was trying to show Rails how Ruby on Rails, why they were insecure by default, and they weren't really listening to him. So he actually found a mass assignment vulnerability that allowed him to commit any code to any repository in GitHub. And he did this by, the vulnerability was against the public key model. So the public key model had a user property, and he was able to take his own public key and make the user property point to the GitHub Rails user, so that he could use his own public key to commit code to the Rails repository. So partly what I found is that mass assignment, due to instances like that, is actually quite well known in the Ruby on Rails community. There's plenty of warnings about it. Their Brakeman static analysis scanner, throws up loads of alarms if it thinks that you're doing it. And so Ruby on Rails, while they were originally the most vulnerable sort of web framework to mass assignment vulnerability, these days they're probably one of the most secure when it comes to this particular vulnerability class. However, it's much less widely discussed in Node.js. So again, I thought, in terms of making the most value out of this research, using this mass assignment vulnerability against Node.js frameworks that are out there is very likely to result in some good findings. So my next step was to actually look at the different frameworks in Node.js, and there's about 1 billion of them, and find how they could possibly express, these mass assignments vulnerabilities. And there are a number of different ways that they persist data and properties to user models. So you've got Mongoose using find one and update. You've got loopback, which uses update attributes, but then they have separate ACLs for deciding which users can affect which properties. Then you have this Adonis.js, where they have about 10 different functions that could be vulnerable. So I just basically went through and I listed all of these different things, all these different patterns, and then just started plugging them into grep.app and seeing if they came up with anything. And it didn't take too long before I had a hit with user.update attributes on free codecamp. And I got quite excited when I saw this, because something that I'd found earlier is that free codecamp is actually the most starred repository on GitHub, with about 380,000 stars. So any finding there would automatically be, interesting at least. So what is Free Codecamp? It's kind of like an online boot camp for learning programming. It's a non-profit based in San Francisco with about 40 employees. So looking a bit closer at the actual finding here, it turned out to originate in this update user flag function. And it's a little bit confusing to see, but this line 208 here, it's setting a constant of update, which is request.body. So it's really similar to the example that we were looking at earlier, where the request body is then plugged straight into this user.update attributes function without any kind of filtering about what properties are actually being saved to the user. And this was behind a API route, a put route /update user flag. So this looks quite promising. The next step is to work out, are there actually any properties of the user that are sensitive that we probably shouldn't be able to modify? And so I found where the user is set in the free Codecamp code. And there are quite a few interesting fields here. There's no concept of an admin user in free Codecamp. However, all the certificates which you earn from studying and doing coursework on the website are simply just stored as part of the model. So you have is backend cert, is full stack cert, for example. So ultimately, the exploit, all that it required was making a put request to this endpoint and then setting all of these properties, which I shouldn't be able to set. Obviously, I also had to set is cheater false and is honest true. As part of that. And, so I sent off that request and I looked at my profile, and then, next thing I knew, I had a whole bunch of certificates signed by Quincy Larson, the head of Free CodeCamp itself. So yeah, there are some of the other certifications I had on my profile, which I worked out amounted to over 6,000 hours worth of studying, which I didn't do. So I reported this to their team, and they were really good at fixing it. And the way they decided to fix it is by listing all of the keys, the properties of the user which you should be allowed to modify, and then filtering out any properties in the request being made which were not part of that list. So quite a simple fix, and one which works well. So we're getting near the end here. Don't know if I've been a bit faster than I expected, but the takeaways for the defense. So first of all, I just wanted to talk about how you prevent mass assignment. So you saw one example just there of how Free CodeCamp filtered out allow listed properties. But there's actually a way that I prefer, the second way, which I see being done in lots of developers in a more modern way, which is that you write specific API routes to modify each particular property. So you would have a API route just to modify and update a user's email address, one to modify their username. You don't do it all in one function and then try and filter later. It's just a safer pattern, even if it requires a little bit more repetition. The other thing that I suggested earlier was that GitHub maintainers can catch low-hanging fruit by enabling CodeQL scanning now. It's super easy to do in GitHub, and although I don't think it would have caught this particular vulnerability, they're always improving the CodeQL rules, and it's likely that this kind of thing would be caught by it eventually. So the takeaways for the attacker, this is very anecdotal evidence, but does it disprove Linus's law? This has been there for 5 years in Free CodeCamp, this particular vulnerability, and it makes you think how many eyeballs are actually looking. Of course, although it has a lot of stars, this particular repo, most of them are probably from beginners who are using Free CodeCamp to learn, and not actual open source contributors who want to modify Free CodeCamp itself. So it's potentially not the most. It's very much anecdotal evidence for the point, but it does make me think. There are loads of bugs out there. There's tons of stuff out there that you can find on GitHub. When I was doing those searches on grep.app, all kinds of stuff was popping out. This was just the most interesting one to talk about today. And yeah, finally, GitHub's code search is significantly improved from where it was before, but still, if you're getting frustrated using something like GitHub Search or various other platform provider tools, it often requires just finding another tool that's out there. Because it took me a while to find grep.app, even though I was specifically looking for search engines that could help me do this research. It was only quite late that I suddenly discovered it, and it was exactly what I needed, and just had that kind of built-in relevance factor. So yeah, hopefully from what you've seen from this talk, I've given an idea about how anyone could really go out there and probably find more vulnerabilities. Just change the vulnerability class, change the language, start plugging in these vulnerable code patterns into grep.app, and then seeing what results from it. It's quite fun to do, and in future I might have another go and see what else I can find. Yeah, that's pretty much it. Does anyone have any questions? Hi.
What did you get for what did Free CodeCamp give you?
Unfortunately, they were non-profits. They didn't give me loads of money, but their CEO did tweet out a little kudos for finding that, which was, that was nice.
How many repos did you find doing this search that had the same vulnerability? That's the main advantage of this kind of search, is that you find lots of places with one vulnerability. How many did you get this time?
So, do you think how many vulnerabilities did I find in total as mass assignment?
Yeah, out of this research project.
Yeah, so I found loads, and the problem was that most of them were in repositories which seemed like they might be used somewhere or that they were dead. There was like this EU search engine where I found that had about 400 stars on GitHub. I found mass assignments in that, but I couldn't find anyone to talk to, and they were Spanish, and I didn't know how to tell them you have a vulnerability in Spanish. There were just basically lots of things like nothing that was in the big leagues, but there were just lots of smaller scale projects which probably are being used in various ways, which were vulnerable to this particular thing. And the thing I found quite quickly is that following up and with all these people and telling them that it's actually really hard to find who to contact or where to go to or whether anyone's actually going to care or listen to you. So I generally, didn't really bother with it. But I guarantee if you go out and try that, you'll find a lot.
I was just wondering what was the second most interesting vulnerability that you found when you were doing this research, the next one down on the list that maybe you would cover, if not this one? Yeah,
that's a really good question, because I did start with insecure deserialization actually first, and I thought that would be the most promising one, because until recently, I think it's changed, the behavior has changed, but simply using YAML.load in Ruby, for instance, or some other languages automatically exposes you to a potentially remote code execution in things like, in an application security context. And I did look for that, and I don't think I had much success in finding stuff in top GitHub repos. I didn't really look much beyond mass assignment, actually. I just kind of drilled very deeply down into that one particular vulnerability class, but I'm sure there's others as well that would also yield similar results.
You mentioned Ruby and Node.js. Are there other tech stacks or languages that this appears in, or is it like mainly those two, or?
Yeah, that's a great question, actually. So in my normal work, I would say probably 75% now of kind of newer web apps being made, at least, are written in Node.js or various Node.js frameworks. So it's super common, and also, but it's a very diverse ecosystem where there's so many different frameworks. It's not like Ruby on Rails where there's kind of, one very solid and feature-rich framework. There's a whole bunch of people doing things in all kinds of different ways and building lots of stuff from scratch. So it's actually really the ideal place, I think, for finding stuff like this, because there's not really been a systematic approach to squashing certain types of bug classes like there have been in things like Django and Ruby on Rails. I also think you might have some success doing this against Python as well. But again, probably the low-hanging fruit is going to be stuff where they're not using the really common frameworks. They're using stuff that's a little bit off the beaten track.
Thank you.
I think that's everything.
At the front, there's a question.
I apologize.
Thanks. I was just wondering, the fact that you couldn't find large repos that had this problem, and that many of the repos you were finding were for one reason or another difficult to inform that they had the problem. Do you think that might be support for Linus's law, that in those cases where it was easy to inform, someone had informed already? It just seems that might actually be support for...
So you think that the repositories where they've made it hard for them to contact them, they probably have been found by several other people before. But
I personally had the experience of trying to update people with you have vulnerability, and it being, for various reasons, just eventually I gave up.
Yeah. I can understand that for sure. And I think it gets, after that happens to you a few times, you realize it's not really worth bothering here. And I guess this is partly why bug bounty programs became so popular, because they created a formal process by which you could at least get listened to, even though sometimes that doesn't always go to plan either, the disclosure process there. But yeah, I agree with you that it could well be that several other people have tried doing similar things before and found these two and just also hit a brick wall.
It reminds me of that story of like the B-52 bombers or something, not 52, it's World War II bombers, where they were looking at oh, these bombers are coming back with holes in these places, but it was like, well, what are the ones that aren't coming back? Because we don't know where the holes are. That missing group seems to, in this case, be the ones that have already been informed on, if you know what I mean. So
yeah, that's a very good point. So drawing any kind of conclusions from what is, not particularly systematic research here would probably be, too hasty to do. That's a very good point.
So thanks. Just like one point, do you know what frequency grep app reindexes? Because maybe you have the same problem that you do with the GitHub, the BigQuery data set.
Yeah, that's a good point, actually. You could obviously probably find that out just by searching for stuff and seeing if it has commits from the last day or so. But on the website itself, they don't really give any information about, much information at all about how it works or how they got the data or how they run it. So, I don't know the answer to the question, but I hadn't considered it, and it's a good point.
Have you checked to see if the bug that you found is still showing in grep app?
I think it shows the fix now, so you can still see some of the same code, but you see the fixed version. And also because certain people forked free CodeCamp over time, and a few of those forks have a lot of stars. They also showed up as well, and I think they still haven't been fixed.
Oh, okay, thanks.
I think now that's everything. Many thanks for the talk. Thank you.